In this video, we're going to be looking at the graph of exponential function and its inverse. Okay, so the graph of an exponential function is going to be inverse to what we call a logarithmic function. In this case, they gave us both the exponential function and the log function, right? But I'm just going to show you how we go to the log function quickly. Remember, we have f of x equals to 10 to the power of x. Now I need to inverse this. I need to invert it. So inverse, remember for inverse, this is y. So we have to switch x and y. So where there was y, I'm going to put x. Where there was x, I'm going to put y. Okay. And then from here, remember, on the previous video, we discussed our logarithms. We said the exponent always becomes the answer. Your exponent in this case is y. And then log base 10 x. Right. Remember I said log of base 10 can just be written as log x, right? If you haven't seen the previous video on logs, please go to the playlist under functions. Look at the video before you watch this one, because all the content in this channel is continuous from the previous video. Okay, perfect. And because the inverse is also a one-to-one function, so we can write it as a function notation, which becomes log x. That's how they got f inverse equals to log x. I was just showing you how we got there. Perfect. So ladies and gents, this table that I have put here, it's a hack. I call it a hack table. I use it to hack the exponential and the logarithmic function. What you need to do with this table is you need to master the exponential function. Just know how to do everything for the exponential function. And then you will see how that will help us to get everything for the log function. Okay, sharp. We're going to work with the exponential only. So the exponential is f of x equals to 10 to the power x. Let's do the x-intercept. Remember x-intercept, x-int, we make y must be equals to 0, right? For x-intercept, y must be 0. So you're going to say 0 equals to 10 to the power of x, right? And in this case, when we solve for x, we can use logs. Now, x equals to log 0, which is not true. Log 0 does not exist. So even here, you're going to say that is not true. If you were to press log 0 on your calculator, it's going to give you math error, basically. Right. Perfect. So x-intercept, no solution. You're just going to say NA or no solution in full. And then we now need to do the y-intercept. Remember, for y-intercept, we need to make x to be equals to 0. So we're looking for f input 0, basically. Our input is 0. Then we have 10 to the power 0, which gives us 1. So when x is 0, the y value becomes 1. And that is your y-intercept for the exponential function. Okay. And then we need to now do the asymptote of the function. The asymptote of the function. Remember, an exponential function always has something. If there's nothing, it means it's plus 0. And that is your asymptote. Your asymptote is this number that you add or subtract on this part. So if there's nothing, it means y equals to 0. So your asymptote in this case, it's y equals to 0. Okay? And then the domain. Let's do the domain for the exponential function. You need to know that the domain for the exponential function is always XER. That is what you need to know. So exponential function, parabola, and a straight line, their domains are always XER. Okay, perfect. And then let's do the range now. The range is easy as well. You do f of x equals to 10 to the power x. So your asymptote is 0. For you to do the range, you write your y, you write your asymptote. And then you either going to insert greater than or less than here, depending on this sign. This sign here, it's positive. If the sign is positive, it means you're going to input greater than there. You see it, so y is greater than 0 is your range. If this guy was negative, your range was going to be y is less than 0. Sharp. So in this case, our range is y is bigger than 0, right? Perfect. And then now remember, for the log function is the inverse of what? Of the exponential. So we know that x will now become y and y will become x. So do you agree that the asymptote for this side will just be x equals to 0, right? And then you're going to switch these points because x becomes y, y becomes x. So now that your y-intercept becomes your x-intercept here. Do you see it? So if the x-intercept is not applicable here, it means the y-intercept will not be applicable here because the x-intercept now becomes the y-intercept there. Right, your domain here becomes the range here. So our range will be y, because where there was x, you put y now. So it's going to be y-er. Ne? And then your domain here, I mean, your range here becomes your domain there because you're going to replace this y with x. So now you have the domain, which is bigger than 0. I'm sure that makes it easier to work with exponential and a log function. Ne? And then now they want us to sketch the graphs, right? We have investigated the properties. They are just switching. Now let's sketch the graphs and see. I'm going to sketch the graphs here. We're going to sketch the graphs there. Sharp. So I'll say 1, 2, 3, 4, 5. I'll just split it into 5s. 3, 4, 5. 1, 2, 3, 4, 5. This is my y-axis. That's my x-axis. And then that's my y-axis. 1, 2, 3, 4, 5. Ladies and gents, the first thing that I'm going to always draw is the axis of symmetry line. Line y equals to x. It's always drawn in dotted lines. Obviously, you'll be using a ruler. Me, I'm just using a mouse, so it's not going to be that accurate. That is y equals to 0. You always show it, especially when you draw the graph and its inverse. If you don't show it, you're going to lose some points. You have to show the axis in which the graph and its inverse are reflected. Sure. So I'm going to start by drawing the exponential function. To draw the exponential function, I need the asymptote. I need all the intercept. In this case, I'm going to have the y-intercept only. If I had the x-intercept, I would be sorted. But because I don't have the x-intercept, I have to get an additional point. I can do f at 1, for example. When x is 1, f at 1 is going to be 10. Do you see it? So f at 1 is 10. So I know that, okay, when x is 1, the y value is 10. So basically on the y's now, I'm no longer going to go up in ones. Now I'll go up in 2, 4, 6, 8, 10, so that I can accommodate at this point. Also on the x-axis, I'm going to go up in 2s now. 2, 4, 6, 8, 10. Because remember this point on the inverse, right? This point on the inverse is basically going to be 10 coordinate 1 because we're going to switch it. Do you see? Perfect. Now let's start sketching. I'm going to sketch this graph. So y equals to 0 is my asymptote. I just show dotted lines there to say y equals to 0. And then 0 and 1, it's somewhere here. And then 1 and 10 will be somewhere there, right? And then I don't touch this guy. I touch this point, and then I'm going to touch that one. That's my exponential. Guys, pardon my shape because I'm using a mouse. It's not going to be that of a nice curve. But because you guys are using your rulers and a nice spaced Cartesian plane, your curve should be extremely nice, right? Perfect. And then now let's do the other one. So we're going to use this guy and that guy. Now our asymptote is x equals to 0, which is here, right? X equals to 0. Our point is 1 and 0 now, which is there, right? And then 10 and 1. So 10 will go with 1 there, right? And then we don't touch this guy since it's our asymptote. We approach that point, and then we go to that one, right? Then that is our sketch. We show that this is our f of x. This is our inverse of f of x. And then that's it about sketching. And I'm sure you can see that this graph, the f of x is increasing, right? Why am I saying it's increasing? It's because as we move from left to right, the graph is going up. If the f of x is increasing, the inverse must also be increasing, of which is true here. As I move from left to right, the graph keeps on going up. Okay, perfect. That's it about this video, ladies and gents. If you found it helpful, please don't forget to share with family and friends and advise them to subscribe to the channel of Maths Fanatics 24/7. A luta continua. Tango.